Here in this problem, we need to show that sine squared alpha plus sine squared beta plus sine squared gamma that's equals to 1 whenever we have the following expression. So let's begin with whatever we have been provided with. So here we are provided with the expression 2 times tangent squared alpha times tangent squared beta times tangent squared gamma added to tangent squared alpha times tangent squared beta plus tangent squared beta times tangent squared gamma plus tangent squared gamma times tangent squared alpha. So this value is equals to 1. Now what we're going to do is we're going to divide each term on both sides with tangent squared alpha, tangent squared beta times tangent squared gamma. So let's write it down. So for the first term it will become 2, simply 2. Plus the second term, so we have tangent squared alpha times tangent squared beta. So divided by this expression is going to leave us with 1 over tangent squared gamma. The third term will become 1 over tangent squared. We have beta and gamma going away, so we have left with alpha, and the third term will be 1 over tangent squared beta. So this will be equals to 1 divided by, we have tangent squared alpha times tangent squared beta times tangent squared gamma. Now we know that the tangent function, that is the reciprocal of the cotangent function. So let's write it down here. We have tangent of alpha, which is the reciprocal of the cotangent of alpha. So it does holds true for beta and gamma as well. That means tangent of beta will be 1 over cotangent of beta. Tangent of gamma will be 1 over cotangent of gamma. So we get 2 plus, since we have tangent squared alpha, so we're going to get its reciprocal will be cotangent squared gamma plus cotangent squared alpha plus cotangent squared beta. So this is equals to, similarly, we have cotangent squared alpha times cotangent squared beta times cotangent squared gamma. So this is gamma. Now we are going to use another identity. So we know for a fact that 1 plus cotangent squared theta, so that's equals to cosecant squared theta, which means cotangent squared theta can be also expressed as cosecant squared theta minus 1. Now wherever we have our cotangent squared function, we're going to replace it with cosecant squared minus 1. So our first term will become 2, so that remains as 2. Then we have cotangent squared alpha, which will become cosecant squared. So here instead of theta we have gamma, so we're going to get cosecant squared gamma minus 1 plus cotangent alpha. Cotangent squared alpha will become cosecant squared alpha minus 1 plus cotangent squared beta will become cosecant squared beta minus 1. On the right hand side, also in place of cotangent squared alpha, we're going to have cosecant squared alpha minus 1 multiplied to cosecant squared beta minus 1 multiplied to cosecant squared gamma minus 1. So we can add 2 with -1, -1 and -1, so that's going to give us -1. So cosecant squared gamma plus cosecant squared alpha plus cosecant squared beta minus 1, so that's equals to, now we'll have to multiply these three expressions. So let's keep the first one aside. So with cosecant squared alpha minus 1, we're going to multiply these two expressions. So we're going to get cosecant squared beta times cosecant squared gamma minus cosecant squared beta minus cosecant squared gamma plus 1. Then further simplification is going to give us, so that's equals to, now we'll have to multiply cosecant squared alpha minus 1 to each of the term within the parentheses. So we're going to have cosecant squared alpha times cosecant squared beta times cosecant squared gamma. Then we have cosecant squared alpha multiplied to negative cosecant squared beta. So cosecant squared alpha times cosecant squared beta. Then we have negative cosecant squared alpha multiplied to cosecant squared gamma. So we have cosecant squared alpha times cosecant squared gamma. And finally cosecant squared alpha plus 1. So we have cosecant squared alpha. Next we have to multiply -1 to each of the terms. So we get negative cosecant squared beta cosecant squared gamma plus cosecant squared beta plus cosecant squared gamma minus 1. Now clearly few of the terms will get cancelled out. Cosecant squared alpha from the left hand side and cosecant squared alpha from the right hand side cancels out. Cosecant squared beta from the left hand side and the right hand side cancels out. So does cosecant squared gamma. That also gets cancelled out. Negative 1 also gets cancelled out. And then we have left with 0. So that's equals to cosecant squared alpha times cosecant squared beta times cosecant squared gamma minus cosecant squared alpha times cosecant squared beta minus cosecant squared alpha times cosecant squared gamma minus cosecant squared beta times cosecant squared gamma, which can be now also rewritten as we're going to transpose these three terms to the left hand side to get cosecant squared alpha times cosecant squared beta plus cosecant squared beta times cosecant squared gamma plus cosecant squared gamma times cosecant squared alpha, which is equals to cosecant squared alpha times cosecant squared beta times cosecant squared gamma. Now finally we're going to divide both sides. So let's write it down. We're going to divide both sides with cosecant squared alpha times cosecant squared beta times cosecant squared gamma. So our first term will become 1 over cosecant squared gamma. The second term will become cosecant squared alpha, and the third term will become 1 over cosecant squared beta. So that will be equals to 1. And we know that the cosecant function is the reciprocal of the sine function. So 1 over cosecant squared gamma will become sine squared gamma plus 1 over cosecant squared alpha will become sine squared alpha plus 1 over cosecant squared beta will become sine squared beta. So this is going to be equals to 1. Thus we have successfully proved that sine squared alpha plus sine squared beta plus sine squared gamma, that's equals to 1. Hence proved.